Today I will explain cw2. In this step download the case-based dataset from the public URL and extract it. And the dataset is divided into training and validation directory. And we define image size 1 to 8 into 1 to 8 pieces and batch size 32 to standard size. Remove data from the CNN, and this ensure all images have the same dimension, which require for model training. And in this code, load image from the directory and convert them into TensorFlow dataset. Label mode, int, assign numerical label to classes, and cache, extract, and preferred optimize performed by preloading data and reducing CPU, GPU, bottleneck, and autotone along a TensorFlow to decide the optional buffer size and printing a class name. Ensure we know the label behind being precise. And this step visually is a simple image from the training dataset, displaying 3 into 3 grid to help verify that image are loaded correctly and belong to the expected class. And it helps that issues such as label image or corporate data and provide insight into the dataset distribution. And data augmentation artificially increase the diversity of the training data and render also developing a rotation and zooming prevent the model from overfitting by exporting it to the slightly altered portion of the same image. And this technique improve model or generation robustness. And this defines the CNN model architecture. These are the input layer accept 1 to 8 into 1 to 8 RGB image, data accumulation and recalling a normal image and pre-configuration. A layer extract feature is followed by max pooling for administratively reducing, and the model is faded, followed by the distance layer with RE and artificial for learning a complete pattern, and the broad result of updating, and the final design layer with a small amount of next output a probability for the true classes cat and dog. And here the model is compliant with our Adam optimizers spread categorical cross entry laws suitable for the integer level classes and accessory magic, and early shopping is used to help our training validation laws that not improve tree constants upon preventing of living and saving the best week. And the model is trained on the training dataset and validate on the validation dataset for up to 15 import. Early shopping monitors performance to afford an accessory training. The history show a training and validation accurately and loss for visualization. And this code visualize the model's training and validation accurately and loss over import. Companion training and validation correct allow detection of overfitting and or underfitting, and the stable coverage of both craft indicate the model is learning effectively. And the trained model is evaluated on the validation dataset to make sure it performs on a single image, and validation laws of accurate provide an objective metric to report how well the model generalizes beyond the training data. And this step compares the confusion metric and coefficient report for the validation dataset, and the calculation metric show the number of correct and incorrect prediction per class, while the classification report provide precision and recall effort score and sport and visualization. The confusion metric as a help math improve interpretability, helping identify class that the model subtract with. And the next one, uh, this session display a 3 into 3 grid of the simple image from the validation set and showing pretty set and actual level. It provides visual will to confirm model prediction and analyze for error in a more intuitive manner than memory method alone. And this function allowed adjusting the model weight and any user provides image. The image is resized and normalized or reshaped to match model input. And the prediction is making the image is displayed with a predicate class and is demonstrate how the model can be applied in real scenario. And in the final step, save the train the CNN model in .h5 format, and this allows the model to be reloaded a little for further testing, um, deployment, or integrating into application without remaining. Saving ensure the responsibility and usability of the model. And in this code word implement a completed CNN panel declined for classifying cat and dog, and it includes dataset preparation and data implementation and CNN multiple training, evaluation using multiple metrics, and visual exception of prediction, user image prediction, and model saving. And this approach ensures high accuracy, robust generalization, and practical usability, making it suitable for both academic for and global application. And this is the is my output of this code. The second version, and this is my output. Yes, it is duplicate. That's all I explain this coursework. That's all. Thank you.